FluoRender tutorials. Use zoom ratio display modes for exporting figure panels. The zoom ratio modes in FluoRender can be useful for exporting a series of renderings. To demonstrate, we open scans of the same tissue at different developmental ages. The first sample is at day 1, which has smaller cell sizes. We turn on the scale bar as an indication of its size. The cells in the samples were segmented and selected using a mask. To reorient the cells in the render view, use the function in the paintbrush window. The zoom ratio mode is set by the button beneath the zoom ratio number. The current mode is pixel-based. When the zoom ratio is set to 100, one data pixel is displayed as one render view pixel. We crop the render view to 500 by 500 pixels for export. Click the Capture button to save the cropped render view in an image. We name the captured image according to the zoom ratio mode and zoom value. We switch to the next zoom ratio mode, which is data-based. In the data-based mode, a zoom value of 100 means 1 micrometer is displayed as one render view pixel. We reset the cropping and set its size to 200 by 200 pixels. Then, we capture the cropped render view and save it in an image. We name it accordingly. The third zoom ratio mode is view-based. In the view-based mode, a zoom ratio of 100 means the entire sample is displayed to fill the render view. We reset the cropping and set its size to 500 by 500 pixels. The captured image of the view-based mode is saved similarly. Next, we load a second sample and capture images using all the zoom ratio modes. The second sample is at day 12, which has grown in size. We use the Align tools in the paintbrush window to orient the segmented cells. We set the zoom ratio to 100 in the pixel-based mode. Using this mode ensures that no image reduction or enlargement is applied to the original resolution. We set the cropping size to 500 by 500 pixels. The cropping frame can be moved to include more relevant features. Then, we capture and save the resulting image. We switch to the data-based mode and set zoom ratio to 100. Using the same zoom ratio in the data-based mode across a series of samples allows the captured images to have comparable sizes, even if each sample has a different physical size. We crop and capture it using the same settings as the first sample. We switch to the view-based mode for zoom ratio. Use the view-based mode across a series of samples to ensure each sample fills its panel. We crop the render view and capture the result. The third sample we load is at day 318. Its physical size is slightly larger than the second sample of day 12. We perform the same operations and capture 3 images for all zoom ratio modes. In reality, a user needs to decide on one zoom ratio mode according to how images from a series of samples will be organized as panels in a figure. Typically, use the PixelBased Mode to achieve a clear result free of blurring or aliasing. The zoom ratio value in the PixelBased Mode is also similar to that in a 2D image processing tool. Therefore, clicking the 1:1 button always sets the zoom ratio to 100 in the PixelBased Mode. When all panels of an image share the scale bar, use the database mode and set the same zoom ratio for all captures. It works well when a size comparison of different developmental stages is needed. When all samples are imaged under the same microscope settings, the results from the PixelBased Mode and database mode are essentially the same, except that the actual zoom ratio numbers may be different depending on the voxel size. The fourth sample we load is at day 533. It's more than twice larger than previous samples. Although its XY slice has the same pixel count at 512 by 512, its larger voxel size makes it a bigger sample in terms of physical lengths. Using the PixelBased Mode, we can still see most of the sample at a 500 by 500 cropping. When we switch to the database mode and set a cropping of 200 by 200, only a small portion of the sample is inside of the cropping frame. To assemble panels from samples of great size variations, we may choose between using different cropping sizes or leaving large blanks for smaller samples if all samples are to be seen and share the scale bar for size comparison. Finally, the view-based zoom ratio mode might be the easiest for generating same-size panels, each filled with an entire sample. However, each panel may need its own scale bar as size consistency is not guaranteed. So far, we captured images for all three zoom ratio modes from 4 samples. All samples have different physical sizes. We already cropped each image to the same size for each zoom ratio mode. We then assemble the captured images in Adobe Illustrator as figure panels. To wrap up, using the database mode, when all panels share the scale bar, setting the same zoom ratio across samples to generate comparable sizes. When sample sizes differ too much, choose among cropping, leaving blanks, or varying panel sizes. Use the PixelBased mode when only pixel resolution is of concern. It provides a workflow for those who are already fluent with 2D image processing. At the same zoom ratio, a high-resolution sample also generates a high-resolution captured image. Since physical sizes are not consistent across the panels of the same size, individual scale bars may be added to indicate the physical sizes. Use the view-based zoom ratio mode if you want to fill each panel with a sample, setting the same zoom ratio across samples to ensure each panel is filled similarly. Not only each panel may need its own scale bar, the resolution of a captured image also depends on the render view size. Samples of different resolutions may be enlarged or reduced to fill the panels. Therefore, a high-resolution computer display or capture enlargement may be needed to preserve the original sample resolutions.